Hello everyone, welcome to the more I do this, the more I realize I can speak English. Hello everyone, and welcome to another short video on solving a LeetCode problem with APL. Today we will be tackling problem 1773, count items matching a rule. Now the problem statement says that we are given a vector of items, and in APL this is going to be a nested vector, and each item is a three element vector itself, and those vectors, that three element vector will contain three strings, one that's a type, another a color, and another a name. And then we are also given an additional two strings, one of them is the rule key and another is the rule value. Now the rule key is one of type, color, or name, so it specifies the field that we want to look at, and then the rule value gives us a value, so just a string value that we want to look for in that specific position. So for example, if these are our items and they tell us that the rule key is color, then we know that we will look for a specific color, so we'll look for the middle position, so the blue, the silver, and the gold, and then they say the rule value is silver. So what we need to do is we need to find out how many times the color is silver, and the output here is 1. And another example they give us is this one, and they say that the rule key is type, so we need to look at the first position, and they tell us to count how many phones there are. So there's one phone here, and then there's one phone here, so that's 2. And this example here is so that we don't confuse the type with the name. So phone also appears here, but the rule key says we want to look at the type, not the name. So we look at the first field, not the third one. And that's it. Then we just need to count the number of items that match the rules. Now let's take this example. This is I can't copy this in, so let's type it in. So the input, the items are phone, blue, pixel. I don't need the outermost parens. So phone, blue, pixel is the first one. Then we have a computer that's silver and that's called phone. And then we have phone, gold, iPhone. Is that it? Yes. Okay, so these are our items. Good. Now we also have, I forgot about that, we also have another argument, which is the type and the phone. So the rule key and the rule value, let's pack them together as the left argument. So that's going to be the search query, let's call it query, is type phone. Now what we have here, the items here, this is a nested vector. So one thing we could do is we could mix it so that we have a matrix where each column is relative to a specific field. So then what we could do is we can take a look at the query and use the first element to determine the column that we need to look at. And so in order to do that, we need to know what field name maps to what column. And so what we do is we type in the field names, so that should be type color name. So type color name. Now what we can do is we can take the fields and ask for the index of the query type. What am I doing? Sorry about that. So the first of the query gives me the string. Now what we need to do is we need to enclose it to look for it in this array, and we can see that type is at index 0. If we had, for example, color, then it would be at index 1, and if we had name, it would be at index 2. Now this gives us the column we want to look at, and so something we could do would be to parenthesize this, so we mix it, and now we use the bracket indexing to access the column. So this gives us the column index, and so we want to get the column, and that's the same as saying for all rows pick that specific value. And so we need to use the semicolon here to say that we want all rows. So the numbers here are empty because we want all of the rows. If we only wanted, for example, the first row, and this specific column we would have a 0 there, or if we wanted the first and second rows, or if we wanted the first and last rows, for example. So yeah, so yeah, we can leave this empty to have to retrieve all of the fields that are related to the query that we need. And then what we can do is we can take a look at the second element of the query, which is also the last one, which is phone, and see when it look for the positions where it matches. So what we can do is how can we do this? I think the easiest way is to have the query in here, so the second element in here, and then we do a match each. And again, we need to enclose this so that this is seen as a single thing. Right. And now what this is doing is it's taking the second element of the query and it's looking for matches in the given column. And at the end, we just need to sum these up. Now there's plenty of different ways to handle this. So something else, if you don't like bracket indexing, because you have to, in this specific case, you need to parenthesize the mix of the items, what you can do is you can mix the items, but then if you transpose this, now instead of looking at the second column, what you need is the second row. Or instead of the first column, we were looking at the first column, now we look at the first row, and so we can get a specific row with the index primitive, except that this 0 right here should be computed from the query, and that's again, what is it? It's the fields. I need the parentheses here. It's the fields, and it's the index of the first item of the query, and then we can do the same sort of matching. So let me copy that over here. Yeah, so this is a way to do it. Instead of match each, you can do a match rank. So we can remove this from here, and now it's, what is it? You need to take the whole vector on the left and the scalars on the right. And this didn't work because why? Let's take a look at this. This is, let me cut that. Now these are scalars, right? So, oh right, because then they get fed as scalars. So what we need to do is the right argument needs to be disclosed first, because I'm applying things to scalars. So I'm getting these boxes in the comparison and I need to disclose them. Or we can have, again, we can enclose this and say that we want to find the matches for all of the scalars, and finally we just sum everything. So yeah, this is one possible solution. I'll be very interested in answering. I'm not interested. I'm looking forward to your questions. So if you have any, feel free to comment them down below. And if you want to suggest alternative solutions, you can maybe write them down in a I don't know, pull request or an issue or whatever in the GitHub repository, or in a comments down below. Just add a couple of sentences explaining your solution or your reasoning so that YouTube doesn't delete your comments automatically because of the weird APL glyphs. And yeah, I guess I'll see you in the next video. Bye.